Here's a picture of a dish antenna. This is the parabolic reflector up here, and the antenna itself is just the wires right there, hardware down here for mounting it onto your house. And some people look at this and say, it looks like it's off center. Shouldn't the antenna mechanism be right here along the axis of the parabola? And the answer to that is it really is along the axis of the parabola. If you imagine drawing a section of a parabola here, and the incoming light, say, is coming like this, and you put your electronics here to receive the signal right there at the focus, the mathematical focus of the parabola, that will be right along the line of symmetry of the parabola, or the axis of the parabola. When they manufacture a dish like this, they manufacture the dish out of a section of the parabola, which might be something like that. And that just makes it a little bit easier to put the hardware here. So they have a off-center piece of the paraboloid, but the electronics here are still right at the focus, the mathematical focus. The light comes in and strikes this dish, and it all reflects to that point. Here's a large parabolic reflector. This is a radar antenna, and you see the electronics right up there at the focus. This is a radio telescope. It was back in the 1930s, I believe, that people realized that objects out in the sky, objects that people typically look at with telescopes that emit visible light, usually also emit radio frequency light. And we can see, so to speak, see things in radio frequencies. We can pick up the light that they're emitting of that wavelength with a large dish like this. So these are used commonly in astronomy, what they call radio astronomy. This is part of what they call the Very Large Array, or sometimes just referred to as the VLA, which is an array of dozens of large radio telescopes like this, and they can point them all at in the same direction and simulate a much, much larger dish antenna. And this is the largest radio telescope in the world. It's too big to mount on something. It's in this valley. This is in Arecibo, Puerto Rico. And it's just down in this mountain range, and you see the electronics up here, and they can aim it a little bit by moving that piece around up top, but for the most part it aims in the direction that that part of the earth is pointed in. So it's looking at a point in the sky that changes due to the rotation of the earth. There's another picture of it. This is a solar cooker. It uses the same principle. You see the pot there in the middle. It's right at the focus, and you point it toward the sun, and you collect a lot of sunlight and generate a lot of heat. And these things can get really, really hot. You could get hot enough to easily start a fire right there at the focus, or easily boil some water or something else in a pot. And this is a research facility in France. This is really cool. There's this huge parabolic reflector right back here. It's several stories tall. And then down here, you see these mirrors. You're looking at the back of them. These are mirrors up on the hillside, and you're just seeing a small portion of these mirrors. This is they cover acres and acres and acres of mirrors, and the sunlight comes in and hits these mirrors and is reflected into this parabolic reflector, and then all the light is concentrated at the center there, and they get thousands of degrees of temperature for experiments and research in that facility.